So we've talked about discrete probability distributions, but before we get into continuous probability distributions, we're going to pause and talk a little bit about sampling. So we touched on sampling earlier in the course, but now we're going to spend a little bit more time on it because we're going to be talking about samples for the rest of the class. And so it makes sense to talk about what is a good sample, what are different types of sampling, what if I have errors in my sampling, all relevant things. And we talked a little bit before about how we want a random sample, but now we're going to get into more detail. So let's just review a few terms that we learned earlier. So a population represents all possible subjects of interest. So if I want to say something about all students at UCCS, that would be my population. That's all students at UCCS. And a parameter is a value that describes some characteristic of the whole population. So maybe if I'm looking at average commute time of students, if I was able to find the average commute time for all students on campus, that would be a parameter. And a sample is some subset of my population, so maybe just people in our class would be a sample. And a statistic is a value from the sample. So average commute time for everyone in our class would be a statistic. And our goal is to use a statistic to estimate the value of a parameter. And we're going to talk later in further chapters about how we do that and how we know if a statistic is a good estimate for the value of a parameter. But before we do that, since we're going to be basing everything that we're talking about off of a sample, let's talk about different types of sampling. So a probability sample is a sample in which each member of the population has some known non-zero chance of being chosen to be in the sample. And there are 5 main types of getting a sample, a probability sample, that we're going to talk about. The first is a simple random sample, and it's a sample in which every member of the population has an equal chance of being chosen. So just really the simplest kind of random sample that you can think of. Systematic sampling is where I choose every kth member of the population to be in my sample. So let's say here are the people, I'm going to think about people in my population. Let's see, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, I'll make it 10. Let's say I want a sample with 5 people in it. Well, if I have 5 people in my sample, my n is going to be 5, I would take the total size of my population, which here is 10, and I would divide by 2 and say, okay, if I want to get, I would divide by 5, the size of sample that I want, which is 2. And so to get a systematic sample, I could choose every second member of my population. So I'd go and choose the 2nd, the 4th, the 6th, the 8th, and then the 10th. And those would be the members in my sample, those 5 things. So in general, if I want a sample of size n, I take the size of my whole population, divide by the size of that sample that I want, and then whatever that k is, I choose every kth member of the population, and that would be systematic sampling. Stratified sampling is a little bit different. In stratified sampling, we divide the population into mutually exclusive groups and then randomly choose members from the groups to be in our sample. So a picture I would draw for that is, let's say I'm going to draw now my whole population as just a bunch of things in this big rectangle. And we'll pretend that there are a bunch of people or things in here, whatever. And what I would do is say, okay, I have this big population, and I'm going to divide this up into mutually exclusive groups. So maybe everything in there is a group, there and here. And then within each group, I randomly select some numbers of things in each group to be in my population. So maybe this, that, this, and this. And that would be another way to make a sample. The next one is called cluster sampling, and that's where, again, we divide our population into groups, but instead of randomly choosing within each group, we choose a whole group or a cluster. So if I had the same picture that I had before with maybe a big rectangle and a bunch of dots in it, I somehow divide this into groups or clusters. I'm going to draw the same type of picture I drew before, something like this and maybe this. And then a cluster sampling would be randomly choosing everything in one of these whole groups. This last one should say convenience sample, and that's where we choose things to be in our sample because they're easily accessible. So if I'm thinking about taking a sample of students at UCCS, maybe a convenience sample would be people in our class, maybe because it would be easier to contact them. Or maybe it would be easier to go stand on the corner of a certain street and just ask anyone who walks by to talk to me, and that would be one way to get a sample. But often a convenience sample isn't the best choice because it might not be very representative of the entire population. If I'm only talking to people in our class, or maybe just people outside of Dwyer, I might only be getting a certain slice of the student body. I might only be getting mostly business majors or certain types of students there at a certain time who prefer online or in-person classes. Depending on how I take my convenience sample, I might not be getting a representative sample. And then another thing that sometimes comes up is resampling, and that's where we take many samples repeatedly, hoping that repeatedly getting samples helps us better represent the whole population. So let's practice figuring out what different types of sampling techniques are being used in these examples. So here it says the first Monday of each month, customers who come to a store are asked to fill out a satisfaction survey. So the first Monday of each month, to me, this sounds systematic. It sounds like I'm choosing some interval to look at. It might not be exactly broken up into a certain number of days, but to me this sounds systematic. I'm systematically choosing on Mondays, on that spread out period of time, just on Mondays. An issue with this is this would only be asking the feedback of customers who are there on Mondays. A lot of customers might come in on the weekend or on different days, and this wouldn't take their satisfaction into account at all. Next, let's look at exercise 4. So this says, I randomly select 4 stores in a mall and ask each customer his or her opinion of the latest healthcare legislation. This to me sounds like cluster sampling. We've divided the mall into groups of stores, and then we asked everyone in one of our groups or clusters about their opinion. Let's try number 5. I position myself on a busy intersection of a city street and ask people what their opinions are of a local sports team. That sounds like a convenience cluster. I'm just going to a certain place, staying in one spot, and asking anyone who walks by. So maybe not the best way to get a sample, but it's convenient to me. Number 6 says 60% of students attending a certain college are women. And a random sample of college students is constructed that consists of 60% women from the student population to ask what their opinions are of the college's food service. To me, this sounds like stratified sampling. We've divided the population into women and not women, and then we've chosen our sample so that 60% of our sample is in the group of women. So this would be stratified. And then lastly, number 7 is using computer software. A manager randomly selects 20 employees to participate in a job satisfaction survey. It doesn't give us any more information about how, and this sounds like a simple random sample. So these are some types of sampling that are good to use, are good to understand. In the next section, we'll practice creating samples in Excel using some of these, and talk about what happens if we have errors in our sampling. Maybe our sample isn't a good representation of our population, or maybe whatever parameter we're trying to estimate isn't well estimated by our statistic.